Today we're going to inspect the Gould's JC slurry pump shaft. First thing I'm going to do is give everything a visual inspection. So starting on the coupling side, we can see where the old coupling was sitting looks okay. Either side of that coupling has some severe pitting, some severe wear, corrosion. That could be an issue if you ever wanted to swap out a coupling. And we all know good couplings equal good alignment. So that's something to take into consideration. Next, we're moving up to the lip seal landing on the thrust side, checking for any grooving, which I could just run my finger across this. I can feel wear there. So that's telling me we got some grooving. The grooving itself could possibly be repaired if the shaft was in decent condition otherwise. Next, we will look at the threads on the shaft for the lock nut, checking for any damage, burrs, etc. This shafting threads look okay. Now we're moving to the bearing landing on the thrust side, checking for any fretting or discoloration. That looks okay. Now we'll move down to the radial bearing fit, checking for the same things as we would on the thrust side. Then we'll move down to the lip seal land on the radial side, which we have some grooving here, very similar to the thrust side. And some corrosion here, right after where your lip seal lands. That right there is pretty significant. Again, could be repaired if needed. Now we're moving down to where your shaft sleeve would actually sit. And here we're noticing some really significant pitting. We're seeing some cuts from somebody running a cutoff wheel, probably to remove an old sleeve. Some of this wear is a little concerning because we all know we want to have a good shaft sleeve landing for good mechanical seal reliability and or packing. Next, we're moving to the impeller side threads, just checking them for condition, burrs, nicks, any galling. Those look okay. Now we're going to check shaft runout. Initial setup here would be my V-blocks at my bearing landings. Very critical we're not on something such as the lip seal landing, because our bearings right here. So I have my indicator set up next to my keyway, and I'm going to give my shaft a spin and watch. We are looking for 2/1000ths or less on a shaft of this size. As we can see, we have a significant dip there. So that dip could be concerning, considering this is our coupling side. And a good coupling side means good laser alignability. Next, I would come down and check the impeller sleeve, shaft sleeve side to make sure that is within spec, because we want our mechanical seals running in tolerance. I'm gonna do the same thing here, just spin it. This side has very minimal movement. So I would say the mechanical seal side of this thing, impeller side, is in okay shape. So we're gonna take some dimensional checks on the bearing fits of our shaft. First thing I'm gonna do is come over here, grab my micrometer, and verify it is set to 0 on our standard. We're zeroed out. No changes need to be done to the mic. I will log that on our sheet that we are good, and we will go over to the shaft. So we are going to check the thrust fit on the shaft. I'm going to look at my dimension, follow my chart down, and find the spec Right now we're at number 16 with a tolerance of 3.1502 to 3.1497. The total tolerance would be 5/10. The shaft measurement is 3.1495. So we are 2/10 undersized. The tolerance on these is extremely critical. Being under means it's out. Out is out. So we would also check the radial fit of the shaft, exactly like we did on the thrust side. This fit is also undersized. Overall, the shaft has a lot of issues going on with it. On the coupling side, we have these corrosion issues and pitting. We have lip seal grooving on the thrust end. Our thrust bearing fit is under. The radial fit is under. More lip seal grooving on the radial side. Pitting, corrosion on the shaft sleeve side. So this shaft would be no good to reuse.